Hey kids, the editor and Mr. G coming at you with lesson 6 of our equivalence and comparison of fractions mini unit.
Editor, what are you doing? That's my job. I do the intros.
Well, you always get to do them. We are a team. You need me to teach the kids, remember? Besides, sharing is caring.
Your AI has been killing me lately, editor. Guys, unfortunately, the editor and I have some really sad news today. Cue the somber animation, please. Editor, I just can't do it. I need you to let the kids know.
One time in the 4th grade, Mr.
Hey!
G.
Editor, that was supposed to be a secret between you and I. Incredibly embarrassing. Why would you ever think that was the bad news of today?
Geez, okay. Sorry. Kids, unfortunately, this is our last lesson of the mini unit.
That's right, guys. Tough news, but at times, all good things come to an end. But no time to whine about it. We got some learning to do. Editor, let them know what they'll need for materials for today.
To everyone's surprise, here is my surprise face. You need a paper and pencil.
Editor, you kind of sounded like Dracula on that bit. Today we'll be taking that final step on comparing all the types of fractions using comparison and finding some equivalency. Models are great, but I think we're going to take another step at taking a look at those numbers and what's happening to them, those numerators, those denominators, when we're using strategies of understanding benchmark fractions like 1/2, and continue building that understanding of a whole or a whole fraction. This will help us when we're comparing fractions that may actually be very close in their values. We'll also need to continue to lean on those understandings that we hopefully came to with our last lesson when we were taking a look at improper and mixed fractions. So hopefully with this last step and the learning that you always are doing on your own and with your other teachers, is that maybe you can compare and understand the value of a fraction by just looking at the numbers. Maybe we get to a point where we don't even need to use models or length models. But as always, everyone learns differently and uses different strategies.
That's because everyone learns and thinks differently.
Good point, editor. Especially you. You definitely think really different with that AI. So, without further ado, let's get to that learning target for today. Editor, you're a real go-getter today. Why don't you read it off today?
Okay, using models and strategies based off of halves and wholes, I can compare proper, improper, and mixed fractions.
All right, guys, for the first part of our I do, let's take a closer look. Let's take one bigger step closer to understanding that equivalence of a half, fractions that are equivalent to a half, that can help us with comparing those fractions that may have smaller parts or may be close in value. So, similar to we explored 2 lessons ago, some equivalent fractions to 1/2 are 2/4, 3/6, 4/8, and I even showed you some really small fractions with small parts that are equivalent to 1/2. 6/12 and 8/16. When we explored equivalency to 1/2, those couple of lessons ago, we recognized some things with the numbers. There was something that was happening to the numerators and the denominators. We found that every equivalent fraction to 1/2, 1 was adding 2 in its denominator and adding 1 in its numerator. It was adding 1/2 every time. Or, if we went backwards, it was decreasing by 1/2 every time. So, our numerators were increasing by 1. Our parts of were increasing or decreasing by 1. Our denominators were increasing or decreasing by 2. And there was a pattern. Let's take a look at some patterns when not comparing each fraction that is equivalent to 1/2, but really focusing on one at a time and taking a look at those numerators and denominators and seeing if we can see any patterns. Let's start with 1/2. I know the whole for 1/2 is indeed 2. I also know that if it had a value, and we weren't talking fractions, that 1 part would be 1. I would have exactly 1 part in between my parts of and my parts that make that whole. Let's take a look at 2/4 with an open number line. We know 2/4 is equivalent to 1/2. So, in the case of 2/4, 4 parts make the whole. We have our 0. And we know that there's 2 parts of. That means on an open number line, there are going to be 2 parts in between. There are equal distances between the parts of and the parts that make that whole. Let's take a look at another example. Let's take a look at 3/6. We know 3/6 is equivalent to 1/2. There are 6 parts that make that whole. Always start with that 0. And we know that there are 3 parts of. Once again, we see that there is the same distance, the same value in between that numerator and that denominator, parts that make the whole, and between nothing and the parts of in that numerator. Let's take a look at 4/8. We know 4/8 is also equivalent to 1/2. I know 8 parts make the whole. We always start with nothing. And we're talking about 4 parts of that whole. Once again, there is equal distance between the parts of and the parts that make the whole, and 0 and the parts of. There are, once again, 4 parts in between 4 and 8, 8 and 4, 4 and 0, nothing, and 0 and 4. let's take a look at 6/12. We also know 6/12 is equivalent to 1/2. It looks different, the parts are much smaller, but it is indeed equivalent to 1/2. So I have 12 parts that make the whole. We always start with 0. And I have 6 parts of that make that fraction. Once again, there is an equal value. There's an equal distance between 6 and 12. There is 6 parts between 6 and 12. And there is 6 parts between 0 and 6. Lastly, let's take a look at 8/16, which, as you can see, is once again also equivalent to 1/2. I have 16 parts that make the whole. I have nothing to start with everything when we're talking about value. And I have 8 parts of. Once again, between our parts of and our parts that make the whole, there is a value of 8, or 8 parts. And 8 parts in between nothing and the 8 parts that make that whole. Notice with our parts and our parts that make the whole, it is smack dab in the middle with the numbers. So not only with our models is it smack dab in the middle, it is 1/2, but also with our parts. There is an equal distance between nothing and the parts. And there's an equal distance between parts and the whole, or the parts that make the whole. Every single time. That's mostly because when we're talking about fractions, we're talking about equal parts of and equal parts that make that whole. So when we have exactly half, it is exactly the same distance between 0 and whatever makes that whole, whether it's 2 pieces that make the whole, 4 pieces that make the whole, 8 pieces that make the whole, 10 pieces that make the whole, 98 pieces that make the whole, 100 pieces that make the whole. So that way, when we're comparing things that are less than 1, it may be a good idea to start thinking in our brains when we're comparing fractions how close a fraction might be to a half. Because sometimes we're working with really, really, really small parts. So when we're looking at a fraction and we're looking at that denominator, we can know what the numerator would be if it was equivalent to 1/2. For instance, if I was, for whatever reason, talking about 20ths. Wow, Mr. G, we've never seen a fraction with parts that are that small and have that many parts that make the whole. I would know half of 20ths would be 10. That is because half of 20 is 10. I have 0, 20. Halfway between 0 and 20 is 10. I have 10 parts from 0 to 10, and I have 10 parts between 10 and 20. It's the same distance. It's exactly half. It's equal parts. equal values, 1/2. Or, for whatever reason, if I was working with a fraction that had 10 in its denominator, it had 10 parts that made the whole, I would know that half of tenths would be 5/10. That's because 5 is halfway between 0 and 10. I know it is 5 parts, or 5 between nothing and 5, and it is 5 parts, or a value of 5, between 5 and 10. Let's take a look how we can use this strategy to help us when we're comparing fractions that are smaller parts or unfamiliar to us to help us. Taking a look at comparing 2/6 and 5/8. That is kind of tough. So, a strategy I can use when thinking in halves is first finding what is the half of the fraction I'm working with, each one. So, what is the fraction's half? Secondly, I can think, is the fraction greater than or less than a half or its half? Let's take a look. Let's start with 2/6. The first thing I want to think in my brain is, what is the fraction's half? Well, I always need to start thinking with the whole first. Mr. G has said it a bazillion times. Working with fractions, think about the parts that make the whole first. I know that there is 6 parts to make the whole with 2/6. I know we always start at 0. What is right in the middle between 0 and 6? Well, I know it is 3. I have 3 parts in between 0 and 3, and 3 parts in between 3 and 6. 3/6 would be 6 halves. What the half would be for sixths. Excuse me. Second thing, I need to think, is the fraction greater than or less than its half or a half? Well, I know 2/6 is the fraction I'm working with. Therefore, I know it is indeed less than a half. Let's take a look at the other fraction, 5/8. I know I need to think with parts to make the whole first. I know 8 parts make that whole, and I know we always start with nothing when we're looking at values. What's the half? What is halfway between 0 and 8? I know it's 4. There are 4 parts between 0 and 4, and there are 4 parts between 4 and 8. 4 is the exact middle. It is the exact half of 8. 4/8 would be the half of 8. So, 5/8 would certainly be bigger than its half, because 4 is in the numerator of the half, and I have one more part greater than a half. It is indeed more than a half. If 2/6 is less than a half, and 5/8 is more than a half, most definitely 5/8 is bigger, has more value, is greater than 2/6. Let's take a look at another example where thinking in halves can help us with comparing those tougher fractions. Taking a look at comparing 4/10 to 3/4. What is greater than, less than, or equal to? I can use a mental math strategy. What is the fraction's half? Let's take a look at 4/10. What is the fraction's half? Well, I know that in tenths, 10 parts make the whole. And I know we always start with nothing when we're talking about values. I also know that our numerator is exactly halfway between 0 and 10. It is the middle. I know the middle between 0 and 10 is 5. I know that is because there are 5 parts between 0 and 5, and 5 parts between 5 and 10. The half of tenths would be 5/10. Second thing I need to think is the fraction greater than or equal to a half. Well, I know that I have a 4 in my numerator. 4 is 1 less than 5. And a half, there are 5 parts when we're talking about tenths. Half of tenths is 5. The fraction we are comparing is 4/10. It is 1/10 less than a half. It is less than a half. Let's take a look at using the strategy for 3/4. So, what is the fraction's half? Well, I know there are 4 parts that make the whole in 3/4. When I'm thinking fractions, I think the parts that make that whole to start. There are 4 parts that make that whole in fourths, or 3/4. Talking about value, I know we start with 0. What's the half? What's in the middle? What's in the middle between 0 and 4? Well, I know 2 is halfway between 0 and 4. There are 2 parts between 0 and 2, and there are 4 parts, and there are 2 parts between 2 and 4. So, the half of fourths would be 2/4. What is the fraction's half? 2/4 is the half of fourths. Well, is 3/4 greater than or less than a half? The fraction is greater than or less than a half. Well, 2/4 is the half in fourths, and I'm working with 3/4. 3 is 1 more greater part than 2. It is greater than. Therefore, 3/4 is greater than a half. 4/10 is less than a half. 3/4 is greater than a half. If 4/10 is less than a half and 3/4 is greater than a half, most certainly 3/4 is greater than 4/10. 4/10 is less than 3/4. Another example. Let's take a look at another example. Comparing 1/3 to 4/6 using that mental math strategy about thinking in halves. So, let's think about the halves of 1/3, the fraction 1/3. Well, think about parts that make the whole first. I know there are 3 parts that make that whole. I know we're talking value. We always start at nothing. 0. I need to think, what is the fraction's half? Wait a sec. I don't think there is a middle between 0 and 3. I know between 0 and 3 is 1 and 2. There's no equal distance. 1 is right here. That has 1 part between 0 and 1 and 2 parts between 1 and 3. That's because, as we found out in lesson 4, odd denominators do not have a half. Odd numbers do not have a half. They're odd numbers. So, if a half was right here, which would be a decimal, or 1 and a half, a mixed fraction, I know that most certainly 1/3 is less than half. Let's take a look at 4/6. Well, if I want to think what the half is of this fraction, what the half of 6 is, I know that there are 6 parts that make that whole. I always start with 0. What is in the middle? What is half of 6? I know it is 3. 3 has 3 parts between 0 and 3, and it has 3 parts between 3 and 6. 3/6 is the half of 6. Well, is the fraction 4/6 greater than or less than a half? Well, I need to now look at my numerator. 3/6 is half. 4/6, I have 4 parts versus the 3 parts and a half. 4/6 has 1 more sixth, 1 more part greater than 1/2. It is greater than a half. So, 1/3 is less than a half. 4/6 is indeed greater than a half. If 1/3 is less than a half and 4/6 is greater than a half, most certainly 4/6 is greater than 1/3, and 1/3 is less than 4/6. Let's take a look at one more example for this you do before we begin using this strategy together in our we do. Comparing 1/4 to 2/6, which is greater than, less than, or equal to, using the strategy of thinking in halves. So, asking my 2 questions, looking at these 2 fractions. What is the half of fourths? Well, I know fractions, 4 parts make the whole, and when I'm talking about value, we always start with nothing. So, what is the middle? What is half of 4? What is half of 4 parts to make that whole? What are the parts? I know 2 is in between, is the middle of 0 and 4. There are 2 parts between 0 and 2, and there are 2 parts between 2 and 4. So, 2/4 is the half of fourths. Now, I need to think, is the fraction greater than or less than a half? Well, if 2/4 is the half, when we're talking about fourths, and I have 1/4, 1/4 is certainly less than a half. It is 1 part, 1/4 less than a half. It is less than a Taking a look now at our 2/6. Where do I start? Thinking about parts that make that whole. I know that there are 6 parts that make the whole in sixths. Looking at that denominator. I know talking about values, start with nothing. What is the half of 6? What is the middle between 0 and 6? I know that's, again, 3. There are 3 parts between 0 and 3, and there are 3 parts between 3 and 6. So, the half of sixths is 3 parts. 3/6. What is the fraction's half? 3/6. Next step. Is the fraction greater than or less than a half? Well, I'm looking at 2/6. I have 2 parts versus 3 parts. 2 is 1 less than 3. 2/6 is 1/6 less than the half that makes 6. It is less than a half. 1/4 less than a half. 2/6 less than a half. Uh-oh. Well, sometimes when we're using a strategy, it may not always work out exactly the way we want it to. So in the case of this example, which I did on purpose, 1/4 and 2/6 are less than a half. Mr. G, I can't compare them. What do I do? Well, sounds like we need to use another strategy. You could use a model. You could understand that when we have a larger number in our denominator, the parts get smaller. And when we have a smaller number in our denominator, the parts get bigger. But we also have to keep in mind those numbers of parts. I would suggest, for the sake of this mini unit, that we would use our trusty length model. We would make a visual model to compare 1/4 and 2/6. Or, as you progress with understanding values of fractions and comparing them, we could actually convert 2/6 into another equivalent fraction by simplifying. That's another lesson. Let's use another strategy we've used in this mini unit, that we've learned in this mini unit. That would be easier. Let's use that trusty length model. I know I'm comparing 1/4 to 2/6. We just figured out in our brains they're both less than a half. Tough comparison. Let's use those models. Let's make those holes. I know both these fractions do have a hole. I can make those holes first. I have 1/4 and 2/6. 1/4. Gotta think parts to make the hole first. 4 parts, 4 equal parts make that hole. I also know now that 2 parts is the exact middle. Okay? What about 6? I know that 6 parts make that hole. I need to partition this hole into 6 equal parts. I know there is a middle. We're talking about an even denominator. 3 is our middle, is our half. That means I can partition 1, 2 equal parts, 1, 2 equal parts in between 3 and 6, and 0 and 3. 1, 2, 3, 1, 2, 3. Bingo. Let's plot them. I know 1/4 is right here. I have 1 part of fourths. I know 2/6, 1, 2 would be here, 2, 6. What's greater than, guys? Looking at this length model, 2/6 is certainly greater than 1/4. All right, guys, let's do a few quick redos and wrap up this last lesson of this mini unit. During our redo, gonna need that piece of paper and that pencil. Always can pause to catch up when you're working with me. Taking time, as always, for you guys to have some think time. Using that half mental math strategy to compare fractions. My 2 questions: what is the fractions half? Is the fraction greater than, less than, or equal to a half? Let's think about 5/10 first. What is the fractions half? How many parts make the whole in tenths? We know there are 10 parts that make that whole. We're starting with 0. What is the middle? What is half of 10? What is equally between 0 and 10? If I have 10 fingers, half would be indeed 5. There are 5 parts between 0 and 5, and there are 5 parts between 5 and 10. 5/10 would be our half, working with tenths. Is the fraction greater than, less than, or equal to a half? If our half is 5/10, we're working with 5/10. It's equivalent to a half. Look at that. So we know 5/10 is exactly half. The parts are smaller, the parts are different, in fact, equivalent. 3/8. We need to think of the half of 8. How many 8s is a half of 8? Well, we need to think parts that make the whole first. How many parts make the whole in 8? That would be 8. Thinking about values, starting with nothing. What is halfway between 8? What is the middle? It is indeed 4. There are 4 parts between 0 and 4, and 4 parts between 4 and 8. Therefore, what would the half be? 4/8. Is the fraction greater than, less than, equal to a half? 3/8 compared to, actually, 4/8. Looking at those numerators, 4 is 1 part greater than 3. It is indeed less than half. Guys, if 5/10 is equal to a half, it's exactly half, and 3/8 is less than a half, which is greater? Five-tenths. 5/10 is a half. 3/8 is less than a half. 5/10 is greater than 3/8. Continuing on with that we do. Comparing 3/4 and 6/8 using that half strategy, thinking in halves. 3/4. the fraction that is half of 3/4. We always start with the parts that make the whole. In 3/4, how many parts make the whole? 4. If I want to find half, I need to find the middle between 0 and 4. What is the middle between 0 and 4? That would be 2. There are 2 parts between 0 and 2, and there are 2 parts between 2 and 4. So what is half of 4ths, guys? 2/4. Is 3/4 greater than or less than a half? If we have 2 parts to make the half and 2/4, and we have 3, 3 is 1 part greater than 2. It is greater than a half. Taking a look at 6/8. What is the fraction's half? Need to start with the parts that make that whole. I know 8 parts make the whole in 8ths. Always start with 0 with value. What is the middle between 0 and 8? What is exactly half? I know I am working with an even number. There is half. What is it? It is indeed 4. There are 4 parts between 0 and 4, and there are 4 parts between 4 and 8. What is the half of 8ths? 4 parts, 4/8. Is 6/8 greater or less than a half? Is it greater or less than 4/8? Well, there are 6 parts in 6/8 and 4 parts in 4/8, which is a half. It is indeed greater than a half. Uh-oh, ran into that problem again. Try to use a mental math strategy to compare these fractions. Didn't work out. Both are greater than a half. How do we compare them then? Well, let's go back to a strategy that we're familiar with. Let's do those length models. Starting off with our length model, work with me please. Making 2 holes exactly the same size. Working with fractions that need to be exactly the same size. We have 3/4 and 6/8. Pause the video if you need to. Need to plot 3/4. I have 4 parts to make the whole. I know 2/4 is exactly half. 1, 2, 3, 4. 4 equal parts. I partitioned this whole into 4ths. Make your whole look like my whole. 6/8. There are 8 parts that make the whole. I know 4/8 is the exact middle. There are 4 parts between 0 and 4, and 4 parts between 4 and 8. I need to partition this. I need to have 1, 2, 3. 1, 2, 3. 8 equal parts. Make your 8s look like my 8s. Let's compare. Let's plot these fractions. 3/4. I know there's 3 parts. 1, 2, 3. 3/4 right here. 6/8. I know there's 6 parts. 1, 2, 3, 4, 5. Plot this 6th. What do you notice? Those look the same to me. What does that mean? That means they are indeed equivalent. Different numerators, different denominators, still equivalent. Different parts, still equal. Last we do, guys. Let's do it. Comparing 2/3 to 1/4 using mental math strategies, thinking about those halves. First thing, I'm asking myself, what is the fraction's half? What is the half of thirds? When we have an odd number in our denominator, what does that mean, guys? That means we do not have an exact half. Let's take a look again. 3 parts make that whole. 0 starting at nothing. There is no exact half. 2/3 is 1 part away from 3. It is 2 parts away from 0. But because that it is not a perfect half, we know that 2 is closer to 3, is 1 closer, 1 from 3 and 2 from 0. We know there's less parts towards the whole. It's closer to a whole. What does that mean? It means it is greater than what? A half. If it is closer to a whole, it's definitely greater than a half. 1/4. What is the fraction's half? Well, I know 4 parts make that whole. 0 parts is 0. What is the middle? What is the half between 0 and 4? It is indeed 2. There are 2 parts between 0 and 2, and 2 parts between 2 and 4. That is the exact half, the middle. So, if 2 parts is the half, we know 2/4 is halves. 2 parts of fourths, 2/4 is exactly half when we're working with fourths. Is the fraction greater than, less than, or equal to a half? 2/4 compared to 1/4. Is 1/4 greater than or less than a half? There is 2 parts and 2/4, and 1 part and 1/4. Is it greater than, less than, or equal to a half? It is indeed less than a half. Which is greater than or less than each other? If we know 2/3 is greater than a half and 1/4 is less than a half, we definitely know 2/3 is greater than 1/4 and 1/4 is less than 2/3. All right, guys, so in that in that Google form, you're going to be working on all these learning targets that we've started, that hopefully we have some understanding since we started this mini unit. So, will it focus on this strategy? Absolutely. It will also have all the other learning targets that we've been working on. Why you need to watch the lessons and do the lessons in order. Do the you-dos in order.